In this video, we will introduce Chapter 8, Piecewise Interpolation. So the sections in this chapter are the introduction, which we will go through degree spline interpolation, piecewise linear spline interpolation, quadratic spline interpolation, and cubic spline interpolation. So let's see a brief introduction about piecewise interpolation. In the previous section, where we talked about polynomial interpolation, it was shown that when the order of an interpolating polynomial increases, which is natural when there is a large number of data points, the interpolating polynomial function can highly oscillate between the data points. With a large number of data points, it is better to keep the order of interpolation low. This can be done using piecewise interpolation using splines. Splines are polynomials on subintervals that are connected with a specified degree of continuity. The order of the polynomials is not associated with the number of data points in this case. So we can have k data points and use a spline of degree n, where k can be much larger than n. So if we assume that we have k data points as x1, y1, x2, y2, up to xk, yk, such that they are ordered so that x1 is lower than x2 and xk is the highest, then a spline function y of degree n satisfies the following. On each subinterval from xi to xi plus 1, where note that the interval contains xi and does not contain xi plus 1, y is a polynomial of degree n. The derivatives of y up to and including the n minus 1 derivative are continuous on the entire domain from x1 to xk. And the data points, when chosen such that the spline function passes through them, are called knots. So a spline of degree 0 is a piecewise constant function constructed by simply assuming y to have a constant value on any subinterval from xi to xi plus 1. So as you can see, we just assume a constant value going through our data points on each subinterval. So the zero order spline gives a zero derivative everywhere. If we take the function itself is not continuous and it's constant at all of the intervals. And when you take the derivative of each of those functions within the intervals, we get 0 everywhere. A spline of degree 1 is a piecewise linear function constructed by connecting a straight line between every two data points. So again, all of our interpolating functions pass exactly through our data points, and here we connect each two data points with a straight line. And that gives us a piecewise linear function. So a linear spline function has derivatives that are constant on each subinterval. A spline of degree 2 is a piecewise quadratic function on each interval. So each of these functions is a quadratic polynomial. The first derivative exists and is continuous, but it is not smooth at the data points. So here you can see the first derivative in the blue of our polynomial, and you can see that it is continuous at all the data points, but it is not smooth at the data points. A spline of degree 3 is a piecewise cubic function on each subinterval. So each of these subintervals has a cubic polynomial. The first and second derivatives are both continuous functions. The second derivative is not smooth. The first derivative is smooth, and for this example, which is the Runge function, it provides derivatives that are very close to the actual function derivative. So in the next sections, we will go through how to construct these different degree spline interpolating functions.